again, I think my face will be invisible in Jitsi, but you may remember that previously I had my separate camera setup.
Yeah, some people have their amazing, like, fancy setups, but I don't know anything about that. All right. It looks like the YouTube stream is live. I put that in the channel, and I'm gonna put it on the conf link directly on conf.fennellang.org.
Also, a kind reminder, you might want to stop the recording after each talk, because Jitsi has time limit on total recording size.
Yeah, when we were doing the recording within Jitsi, that was a problem, but we're sending it downstream to YouTube now, so we'll just take the whole thing and splice it down there.
Okay.
It doesn't have that same limit, so that's nice. Algernon, did you want to sound check and screen share real quick? I don't know if I saw that you got a chance to do that.
I think my microphone works. We can check the screen share too.
Yeah, mic sounds good. Thanks.
Yeah. Still, Phil, I remember last year when we were streaming to YouTube, we had issues with the stream. It was stopping. So
looks like the screen share works too.
Yeah, we can see it.
Okay.
The font size seems good.
Okay.
Okay, so I don't remember that from last year. There was so we were still running into those limitations with YouTube. I can restart the stream then if that.
Yeah. So.
Okay.
We just need to keep it in mind because I vaguely remember that we had DC telling us the stream is stopped, something like that.
Right. Okay. Yeah. I couldn't remember if that was this streaming setup or the previous one. So.
It was with YouTube. That's for sure.
Cool. Good to know. Good to know. Okay. Just send this out. And cool. Okay. Give it like one more minute here. And then just make sure all the links are good. Oh, if I put this on here, I'm gonna get a feedback loop. So that's gonna be fun. All right. Okay. Well, we are at the top of the hour now, so let's kick this off. Yeah, thanks for joining us, everybody. Welcome to FennelConf 2025. Excited to have everyone sharing what they've been working on through the year. So, yeah, it was kind of a fun time to look back and see all the creativity in the community and stuff, which I love. So, yeah, we've got a little bit of a shorter agenda this time around, but I think it's all going to be really cool. Really looking forward to hearing all this. So, yeah, we're gonna kick things off with Algernon here first on the schedule. So,
one quick request: can we schedule me a little bit later because I'm a little bit behind?
That's no problem at all.
Yeah, thank you.
Yeah, I was going to be second, but I can go first.
Thank you very much.
That's no worries. Yeah, are you okay being second, or do you want to shuffle it around? We can put you last.
Third would be better, or even last, whichever
Let's do
works.
last. That's fine.
Okay.
No problem.
Okay,
No
let's
problem.
do that. Thank you very much.
Okay. Yeah, no worries. Let me pull mine up here then, and we can kick things off. So it looks like that is working. And I'm gonna get right to it here. Okay, cool. So my talk is called the Floss Stack. I'll get to what that means later, but I'm going to be talking about web apps. So did you know that we have not had a FennelConf talk about web development since 2019? I thought that was a little weird. Up until now, all the web work I've done with Fennel has been through generating static files like the FennelConf website, and maybe like the occasional CGI script when I needed a little bit of dynamicity, like the survey submission script. But for the most part, I just stuck with that strategy. But earlier this year, I found myself wanting to make some sites that didn't really fit that mold. I needed more. So a big part of the appeal of static files to me is I have a host I can publish them to, and there's no sysadmin work, right? I pay someone else to handle that. I rsync it out and forget about it. But these applications, on the other hand, they're built to run on my home server. So as such, the number one priority when I'm choosing a technology is that it has to be easy for me to manage as a sysadmin. It'll be more work than the static sites, yeah, sure, but it shouldn't be too much more. So you have to use Docker at work, but there's no way I'm touching that in my free time. So realistically, this means choosing libraries and things that are either package in apt for Debian, or easy to include in my own projects without a lot of fussing. This also intertwines with my priority of not trusting like any old code I find lying around. If it's in apt, like there's been some degree of review going on, and we can argue about whether that's enough. It probably isn't, but anyway, it's something. It's better than nothing. If I pull something in from Git, then I'm going to review it myself, at least like a cursory glance over every line. So this puts some limits on what I can use, but I kind of think it would be a little irresponsible to do otherwise. So that's a little framing for like where I'm coming from here. Let's go on to the code. So this is Moonmint, and I started looking around and found this. The URL may look familiar. That's because it's another project by Backpackin', the original creator of Fennel. Like Fennel, he also started this in 2016 and then moved on to other projects. So Moonmint is it's based around, it's a web framework that's based around libuv, which is the underlying IO framework used by Node.js and NeoVim. Since Lua doesn't have any built-in support for sockets, any networking program needs some C code to handle these calls, and Moonmint uses libuvs for this, as well as to schedule coroutines. So because it's meant to be used from Lua and not from Fennel, it has some stuff we don't need. There's like a templating engine that's not really much use for us. I like there's a S-expression-based HTML.fnl library that I use for all my static sites. I'm just going to use that for all my HTML. It also has some dead weight bindings to like this ancient version of OpenSSL from 2016 that doesn't really work anymore. But it's also got good support for headers, routing, middleware, and static files. So I thought I'd give it a shot. So this was all for a project I wanted to build my own custom search engine, personalized for myself. So if you are a person who uses the web in 2025, you may have noticed that search is bad now. I've been weaning myself off Google for a while now, but more importantly, I've been reevaluating whether it makes any sense to even have one search engine that can somehow be expected to index the entire web for everyone. So no one entity should have that much power, nor could any be trusted to wield it responsibly. So that's just fundamentally an impossible dream. But we were pretending we lived in that world for a long time until Google self-sabotaged, ruined their index, and now it's not so hard to imagine a world without Google. But what do we have instead? What can replace it? Well, I'm not smart enough or well-funded enough to make a search engine that's good, but maybe I could make one that's bad in a way that doesn't bother me so much. So I focused on indexing data that's likely to be relevant to me. Links from my own bookmarks, links I posted to social media, or links that were posted by people I follow. So take a look if you're curious about this in the why section here. I wrote a lot more about the motivation, and I think that could be like a whole separate talk. But I just want to focus more on the technical stuff. So it turns out SQLite has a full text search engine built into it that makes this actually relatively straightforward. There's a lot more to get into around the indexing and crawling side, but from the web side of things, MoonMint made this pretty easy. So I'm just gonna search here, and you can see it finds my post from my friend made several years ago critiquing the Excelsior class Starship design, which is a link I wouldn't have been able to find otherwise. So that's cool. And yeah, in my search engine, obviously I have to make HTTP requests, but unfortunately the HTTP client situation with Lua is not the best. It would seem like the most obvious thing would be like use curl. Unfortunately, there's like a bunch of different libraries that are all called Lua curl, and they're all a bit of a mess in terms of maintenance, documentation, and packaging. I wouldn't really recommend that. The Lua socket project has an HTTP client, but there's no HTTPS support. There is the Lua sec project adds HTTPS support to this, but their code base makes some pretty questionable decisions. Like they have certificate validation completely disabled by default, which I think is a really bad idea. So I can't really recommend that in good faith. There's a pure Fennel HTTP client as well, which we'll be hearing about more in a little bit, but it also doesn't support HTTPS, so I couldn't use that. And so at that point, left with basically two options: Lua HTTP, which has a kind of a clunky API, but is like easy to install. And then there's Lua HTTPS, which is a client created for the Love2D game framework. But it's easy to use independently, and somehow it even works on mobile. But there's one downside: it does not provide a streaming API. So you can't do anything until the entire request completes. There's a bit of a drag for my search engine. It means I might get a link to an MP3 or a GIF, and I can't read the headers to check the response type until I've already wasted time downloading the entire body, which I just have to throw away. So it works, but it's kind of inefficient. And the reason I can get away with it is that I'm only making HTTP requests during indexing time, not while the web app is running. If I had to do that, like the blocking requests would be a deal breaker. So anyway, check out my search engine. Maybe you'll like it, but more importantly, maybe you'll make your own search engine because it's actually pretty easy and fun. Yeah, so once I got my search engine working, I thought to myself, like, hey, that wasn't so bad. Making a website is easy, actually. So my next idea was to make a site where people could make bots for social media. Lua and Fennel are just ideal for this, right? Because they're so easy to sandbox. You can make a site where end users post their own code and you can run it and you don't have to worry about it for the most part. And it's also really easy for end users to learn Lua or Fennel and make something fun without like learning the entire ecosystem or language, just a little bit. So here I made a bot that scrapes show times for the local theater's WordPress from the local theater's WordPress account and post them to this bot account. So you can see like it's so simple, right? It's just going to take this URL, and this is a an HTML parser, and it just extracts finding various elements using selectors and puts it into a table. So anyone can log in and like check the source for this, and they can remix it and make their own version of it, which I think is really cool. So here's an example of a post that was made by that bot that it got off the WordPress HTML. So for the site itself, yeah, the bot, the code for the bot is super simple, but the code for the site is, obviously a lot more complicated than the search engine. You have to edit the bots, remix them, test them, scheduling when they run. But the main challenge here was the HTTP client. So, this bot is going to make an HTTP request to this URL, and I couldn't use the blocking client for this because I can't allow like one slow server to lock up the whole site. So at that point, I was like, okay, I have to go back and revisit Lua HTTP, which does have good support for streaming requests. I could check the headers before downloading the body. I could stream the body results back in and yield when it took too long. And that allowed me to have a much greater total request timeout than I otherwise would have. But I can't fully recommend Lua HTTP yet because it has this serious bug when you're constructing requests where like the order that you do things is very particular about that. And if you get it wrong, it gives you this nonsense error message. So I'm working with the maintainer. Hopefully we can get this fixed in the next version, but it might take a while. Yeah. So one of the cool things about Fedibot Club is that it allows users to log in, but I don't have to store like passwords or implement two-factor auth or save like hardly any personal information. All that happens over OAuth. It allows users to indicate what server they have an account on already and just delegates all the hard login parts to that user. So I factored out all the boilerplate login code from Fedibot Club and put it into this skeleton repo that gives you everything you need for your own web app. The login stuff is about 100 lines of code, and the whole skeleton is under 300, which includes a REPL, a database, and a capabilities system. Yeah. But yeah, there's the OAuth flow. It logs you in. It shows who you're logged in as, and it shows who else is logged in at the same time. So it's just a demo, but you can kind of see how that all fits together. And the source for that is at the bottom there. Oh yeah, so all these links are going to be linked to from here. So I'll just put this in the chat, and you can click through to any of that you're curious about. Yeah, cool. Okay, so yeah, this is about 300 lines, which includes all the web stuff, login, REPL, database, and a capabilities system. So great place to start if you want to make a web app. Which brings me to capabilities. Yeah, okay, so capabilities, aka OCAPs, object capabilities. If you saw my 2022 FennelConf talk, I'm a huge fan of capability systems. So the way this works is like you set up this table when you start of all the things that your system is going to need to do to reach the outside world, I/O basically. And you build this table called caps, and then you set the _env local, which turns on sandboxing and limits all your globals to only reaching things that are safe, like string, table, math, but prevents you from loading things that could reach the outside world. So that only is going to go through your caps table. And so anytime you need any of that, it needs to be passed through as an argument from one function to another. So this results in some really excellent security properties, but it also gives you some useful code organization properties. We can tell by looking at a function's arg list whether like that accesses the outside world or not. For example, here, post login, you can tell here it takes the capabilities table, the caps there, and so like, okay, the DB is here. Any old function can't load the DB, can't reach the DB. It has to be given that as an argument. So you can see here, it takes this, destructures it, passes it on to this getter register function. And you can see the R on the arg list here, like, oh yeah, this function definitely takes the DB. This function does not take the DB. It doesn't take anything except instance. And you, because of the way the sandboxing works, you can know that this is not going to shell out. It's not going to like touch the disk at all. It's going to be purely dealing with whatever argument it received and nothing else. So that really helps you focus and understand the code a little better. So honestly, I would never consider writing any services in Fennel that accept untrusted input without a capabilities system, unless they're completely trivial. Like this is just so much better, and I'm never going back. So yeah, check that out. What else? Okay, so this does not actually use MoonMint. Once I realized that I needed Lua HTTP, I started to rethink my dependency on MoonMint and libuv, because Lua HTTP, it's not just a client, it can also be used to write servers as well. So I introduced this and along with MoonMint, and my codebase had 2 different IO loops in it, and it didn't they didn't conflict with each other, but it felt clunky and redundant to have both, especially considering, you know, MoonMint was abandoned. So I ended up porting these 2 apps to use Lua HTTP on the server side, which is not exactly a drop-in replacement for MoonMint, but it's pretty close. The main difference is MoonMint supports routes, like it has its own routing system, and Lua HTTP makes you do that on your own. So that's yeah, it's fine. It'd be nice to have that, but it's not too bad to do that manually. The other downside is Lua HTTP uses CQs for networking. So I think CQs is fine as far as functionality goes, but the documentation for it is really bad. Mostly it doesn't matter because you rarely care that there's CQs underneath, but occasionally it comes up like I wanted to add, read from a domain socket for adding a REPL, and I had to resort to trial and error and asking around, but I got it working, whatever, it's fine. Finally, I want to talk about databases and SQLite in particular. So most database libraries fall into one of 2 categories. Either they're relatively low level and expect you to just write SQL as strings embedded in your regular code, or they're higher level and they generate SQL for you from data structures. SQL as strings really annoying to edit because like you don't get any of your editor SQL abilities. It just thinks it's a string. So syntax highlighting goes away and stuff. But in my experience, like the higher level libraries that generate SQL, they tend to, you know, only get you so far before you run into limitations and weird behavior. It's better to just write the SQL yourself. You can't avoid having to learn SQL, so just use SQL. So at work, I've been using this library for Clojure called HugSQL, which lets you write your own SQL, but it keeps the SQL in separate files, and you still get your editor's full power instead of, you know, just strings in your program. And this has worked so well that, like, again, I never want to go back to any one of the other approaches. So I've done a rough port of this to Fennel called LightHug, which is right here. It's slightly different from HugSQL because it has each query in its own file, and HugSQL has like 1 file per table. But this allows us to avoid parsing SQL, which is a pretty big dependency. But it retains, I think, all the other advantages. You declare, so you write your schema and your, you know, 1 file for each query you want to make, and then you initialize this, give it the path to your database, and then a table of so these would correspond one-to-one with these files, but you have to tell it what kind of query it is. Like this one, you know, bang, it just does an insertion, it doesn't return anything. This one's going to return 1. You might have other queries that return a list of results or an iterator, and you can nest the queries as well. But this is so you get back from this init, you get back a table that just has these functions in it, one function per each entry here. You just call them and you get back your tables or whatever. So this works really well. It uses parameterized queries, of course, for everything, so there's no SQL injection or anything. But yeah, the main downsides are mostly things that just come from SQLite, like you don't get UUIDs or datetime types. The error reporting is not great in some cases. You have to opt into strict tables, but once you do that, like it works pretty well, and it fits the Lua ethos of doing a whole lot with very little resources and complexity. So, okay, so this gets all the pieces together now about the Floss stack. It stands for Fennel, Lua HTTP, OCAPS, and SQLite. So everyone knows for you need a good acronym for a stack to take off. So I'm expecting now that this will become very popular now that we have that. And then one of the things I've been thinking about is whether I should turn this into a framework that you can install as a library, which is, the way most of these work. 300 lines is not nothing. But on the other hand, I think there's some value to not hiding it away, so you can see what's really going on, like leaving it exposed, like rebar sticking out, so you don't forget what it's made of. I don't know. This approach, with the skeleton that you cloned, seems to have worked pretty well for Alex's Love2D repo. So, that's kind of what I'm going with here. At very least, I don't feel like becoming the maintainer of a web framework right now. Maybe someone else does. So I'd be happy to hand that off if you're like a big web person. But anyway, yeah, please take a look at this if you're interested in making a web thing. And you might have some fun with that. Finally, I have like one more web project, just for fun, that's a little bit ridiculous. So I don't know if you remember back like a decade ago, someone made a social network where all you could do is say yo, and somehow it became this big sensation, and then of course it shut down like 2 years later. Well, after I've been running my own social network server for a few years, I realized like how easy this would be to rebuild, so I did it. My first build, I forked GoToSocial, which is an existing social media server, and I just edited their validation rules to reject, like anytime you would try to post something and it wasn't yo, it would be like invalid post. And that worked, but it was kind of a pain to keep the fork maintained. Like I'd have to rebuild when they made a new version. I was falling behind the upstream releases. And then I realized I could use the completely stock server. I could just put a proxy in front of it. So that's what GoToSocial does. It's just a proxy that sits in front of GoToSocial, and someone tries to post a status other than yo, it rejects it. So it's like 58 lines of code, nothing to it. But if you want to, sign up for a social network and you enjoy saying yo, you could join this one. It's pretty fun. So yeah, that's all I have. And thanks for listening. I think we do have a little because we have fewer presentations. We do have some time for questions. So if you are in the in the chat or right here, go for it. Andre, what's up?
Yo, have you considered using depth.fnl for making a library that you can easily install with your minimal web framework?
Using depth.fnl. So I let's see. I didn't do that for so there's kind of like two sides of that. There's like using that for pulling in like database libraries or like an HTTP client, or then there's like publishing it and having other people use it that way. So I think for the dependencies for my own apps, it didn't really make sense for me for my search engine. There's just some dependencies that were never going to work for that. Like it needed pandoc to convert the HTML into text. So I pretty much had to use apps for my dependencies there. But I think if there was a library that was like I like one of my existing approach wasn't gonna work for, then I definitely would have looked at that. But for the libraries I was needing, it was either like so weird that it wouldn't work, or it's like one file. I'm just gonna put it in my code and forget about it. So
yeah. I meant the repo with your main web framework itself. So, for example, if I want to build my website with this stack, I could pull it in with depths and then add additional libraries. Because as far as I heard, there were only like Lua libraries there, and maybe some Fennel code as well. So like adding Lua HTTP, the library for SQL with depths should be possible. Yeah.
Yeah. No, I would definitely consider that if I was like, if I decided like I want to turn this into a library that people can pull in like that instead of just using the skeleton that you clone approach, then I would look into that. And so it's not like, but it's if I was going to do that first, I would have to really think through like stability of the API, like make sure I'm exposing what is the exact thing that I'm going to commit to not breaking. Which I don't really have that problem with the current approach. So it's something I would consider, but it's a little more of a commitment than I'm like really ready to make right now. But I think it would be useful if I decided I wanted to do that. Yeah.
Okay, thank you. Your answer was discarded because it didn't start with yo, though.
Yo.
Thank you.
Yeah, sure. Looking at the chat, and I don't see any other questions there. So in that case, I think we'll go on, and I think Andre is next up. So
okay.
Yeah. Oh, I was gonna restart the stream so we don't hit the limits there. So I'm gonna do that real quick. I hope that wasn't too disruptive for the folks who are watching. Let me just make sure that I realized that could have changed the URL. So what happens? Okay, no, I think we're good. Yeah.
Yeah.
All right. Go ahead, take it away.
Yeah. So the sound, the screen sharing is good. Yeah.
It's good. Yeah.
Okay. So hello everyone. My name is Andrew. I'll be talking about my HTTP library for Fennel that I wrote. Not strictly this year. I worked with it like for probably 2 years already, and I did some major improvements lately with like supporting more of the HTTP spec than before, but I think it was like early in this year. So like, I'm basically writing this talk as I remember doing it, and it's full of like inconsistencies. So if you have questions, if you have thoughts, you can interrupt me mid-talk. I'm okay with that. I will like explain myself better if I didn't say something clearly enough, or if not, we can always discuss this afterwards if you have questions. So this library is mainly my like interest in experimenting with Fennel, with Lua itself, and with HTTP, because at some point in my life I looked at the HTTP spec and was like, hey, you can do it rather easily yourself, right? It's not that complicated. At least the HTTP 1.1 version of the spec, not like HTTP 2, which requires HTTPS, and it's a lot more nuanced than that. So I was looking at it, and decided that, okay, I will try to make an HTTP client. Not that I like pursued something of making the best HTTP client for Fennel, because I knew that, like Phil described in his talk, that there are real problems with some other HTTP clients. No, it was just my experiment with HTTP. I wanted to use my other libraries that I've made over the years to see if they are applicable in this in this experiment. So I did. And FennelHTTP is a library written from scratch. It uses like its own HTTP parser, its own HTTP like encoder, and it supports the HTTP 1.1 version of the spec. It has asynchronous operations, which was one of the pet peeves I had with Lua Sockets HTTP clients that they have in their library. And it also supports streaming, because that's another like my pet peeve with Lua Sockets HTTP client. And I also included a small server implementation into this library as well, just to see how well it works like in both ways, as a client and as a server. So let's jump in. This library is rather complex in its organization. It has some dependencies. It has a lot of files. So I recommend, if you want to try this library, to install the deps dependency manager for Fennel that I made earlier, and then install this library with the deps.fnl file like shown on the example above. And this presentation will be somewhat interactive, so I'll be executing code running here. So you can see I've just required this library, and it has 4 main modules. It also has a server module, but I'm not going to show how it works. So we are mainly looking at the client module, JSON, readers, and URL. So let's dive in, and a quick overview of this like library is that its main modules are separated into clear like parts. So the client module gives you all of the HTTP methods like get, post, put, and others available in the HTTP spec. Then there is a JSON module which supports encoding and decoding JSON. And this module also was written by me from scratch, because I was looking at other JSON parsers and encoders available for Lua, and almost none of them had everything I needed for this kind of project, so I made my own. Maybe I didn't look too closely into them, so maybe there are like libraries that handle all of my cases, but it was fun to make your own JSON like parser and follow the spec to some degree. This library also supports streaming, so I had to write my own like streaming library for creating readers, as I call them, for strings, for files, and I also threw in an implementation that converts Lua Sockets LTN12 like streams into readers. So you can use, if you already have some LTN streams, you can just convert them and they will work. And also this client features an URL parser implementation. So it can parse URLs, it can encode URLs from data, and it also provides a helper function for URL encoding like parts of the URL, so it will remain secure. And a model with an asynchronous HTTP 1.1 server. So a quick overview of the client. I will be using httpbin.org as a means to show how it works. And here we can do a simple like GET request here. And as you can see, unlike something like HTTP client in the Lua socket library, for example, this thing returns us a table, and this table contains the body key, which has our body as a string here. It has a headers key, and all of the response headers are stored there. And we also do some parsing here. So, for example, we parse the content length and store it as some metadata in this same table. So this data format was inspired by CLG HTTP library, which was my like main inspiration interface-wise for this library, and I kind of like it because it's just data which you can query, you can like transform it, and use it pretty much with everything you have in your standard library for Fennel. However, like working with body when it's a string is a bit hard. So here comes the JSON parser, and we can actually ask this client to parse body as JSON here, for example. So you can see the body now parsed into a Fennel table, and we can work with it as we would in our code base normally. We can also ask it to return us a stream. Here I have a small bug in my presentation, like software inside Emacs. It for some reason doesn't show like the reader here, but just imagine after the body key, there is a reader object, which is specially encoded into like pretty printed form for a reader. Basically how we encode functions in the REPL. When we print functions, we have this like hash, angle brackets, and function address. I have the same for readers. And in case of this request, the body was not yet consumed. So it's stored in the reader, and the connection to the server is kept until we like read all of the data from this reader. And for tweaks, I can show you that we can issue post requests, and here again we have our body parsed as JSON. The data that we sent is here because http bin.org just responds us with our own request to the server. So you can see that we sent this and received back all of the rest. This library also supports multipart, and it was an interesting task to support. So we can send multipart, we can receive multipart from the server. Here I'm sending a file. You can see that I'm just opening a file. We determine its file size. We set the file like position back to its beginning, and we also want to stream some text as a stream. So we don't send it all at once. We can stream it like byte by byte, or no, it depends on how I implemented it in the library, and currently I don't remember how exactly it works here. But if we execute this code, you can see that the server correctly received our file, which is our depth file, the text data that was streamed by this readers module that created a string reading from the text we wanted to stream, and also just text data that we sent as is. So multipart also works. I don't have an example of receiving multipart because, first of all, working with multipart on user end is a bit more complicated. I will go into that a bit shorter later. But also HTTP bin doesn't support like responding with multipart requests, so it was a little harder to make an example that is easy to follow. So we'll skip that for now. A quick overview of the JSON library, and as I mentioned, I made it because I first wanted to experiment with JSON, and I also had some like additional features in mind that I needed for this library. So you can encode pretty much any data that is Fennel data, I mean, apart from like functions and other types that are not found in JSON. So it will throw an error. And here we can see that I have encoded a table. I can encode a sequential table. So it works as you would expect. You can also decode stuff. And one of the differences from other libraries is that my library supports nulls in JSON. So as you can see here, we have nil inside the table, and it's a bit unusual for like Fennel users because when we have nils assigned to keys, these keys are removed. Now, this is not how JSON works, however, so I had to make an additional like bookkeeping while parsing because we may want to restore these nils after we encode this back. So round trip is fully supported. We can decode this as nil and encode it back, and it still shows as this JSON. However, just note that this is a real nil. It only appears here when we print this decoded object because if you try to query this field, it will contain a proper nil. So it doesn't exist in the table for real. It just kept inside of the metadata of parsed object, and FennelView just knows how to render it. So you can still use this in conditions. It's not like a special object or something. But this library has a null object that you can use if you need to encode null specifically into JSON. And again, that's something I haven't seen in other libraries. Next up is readers module, and we can create readers, for example, from a string, from file, as I mentioned. And here it just creates this kind of object called reader. It has an address, and it's a special table in reality that supports some methods. For example, read can read an amount of bytes from this reader, and this reader is consumed. So if we continue reading by 4 bytes, we will read the reader up, and now it will no longer return anything. If we recreate this reader again, you can see its address changed. We can also use the method for obtaining all of the lines in this reader. So it also works on files, it works on strings, and later on we will see how it works on HTTP body, basically. And the URL module, which can parse scheme, host, port, user info, pass, and query and fragment parts of the URL. Here is a simple example. We can parse this kind of URL. We see that it has a host HTTP bin, pass is get, port is 80, because that's the default port for HTTP, and also scheme is set to HTTP. This object has a toString property, so we can convert it back. You can see that it assigns this port here because it contains the port specifically. But if you want to create URLs from just plain data, you can do it with the URL constructor. So now it only creates URL with what exactly is described in this table. So I think it's a handy library for working with URLs, and parsing URLs is notoriously hard, so I tried to make it as best as I can, but maybe there are some bugs that I haven't yet found, because no one uses my HTTP client, except for me. So back to the client. One of the major features of this client is that it supports asynchronous requests. And again, that's not something that a lot of these libraries do. Ones that can do it use an additional library to give you asynchronous capabilities. Like, again, Phil mentioned in his talk that there are things like libuv, which can schedule coroutines and stuff. There is also CQs, which can handle that too. However, I have my own asynchronous library that implements asynchronous operations without any C dependencies. So I decided I want to try it in some project and use it as a basis for this HTTP client. So actually everything in this HTTP client is backed up by my asynchronous library. So here you can see the call signature is a bit different. We again call the get method from the HTTP client, but we also say that we want an asynchronous operation, and we provide 2 callbacks. Again, this was inspired by the CLG HTTP library, which has this kind of call convention. So we provide an on success callback and on error callback. So if the server responds with anything but 200 to 300 codes, it will call on success. Otherwise, it calls on error for everything greater than 400 status code. And if we execute this, these callbacks will be running in the background for real. So we can execute it. You can see it returns an asynchronous channel, and then we can wait in a while loop on the body until it appears. Body here is just a var that we set in this callback. So it happened in the background for us, and the body is shown here. Why asynchronous request matter for an HTTP client, even though, because Lua is just a single-threaded runtime, so we can't do stuff in parallel. Yet we have async for some reason, and we don't use any C code to create actual threads and stuff. That's because the operating system can actually do stuff in parallel outside of Lua. And when we are dispatching requests to sockets, the socket devices, they can work in parallel because of the operating system that we are using. So here I have a simple benchmarking code for executing 10 requests in an asynchronous way. And as you can see, it takes around 2 seconds to execute 10 asynchronous requests, each of which is a post request, so nothing is cached. And if you try to execute 10 sequential requests, it takes a lot longer than that. It actually takes 3.5 seconds, so 2 times longer to execute this sequentially. The speed, of course, depends on the network speed, and this is not a scientific benchmark. It's just a way to show that sometimes doing asynchronous request can benefit even when we are running on a single threaded runtime. And to compare it with Lua Sockets HTTP client, you can see that actually it executes 10 requests, sometimes even slower than my HTTP client written from scratch. Again, it's purely dependent on network speed here, so don't take this as one source of truth. Try on your own. Maybe HTTP client in Lua Socket will be faster for you. I don't know, but for me, at least, while I tested, my client is slightly faster and twice as fast when we are doing asynchronous operations. So now let's look inside, and this library is, as I mentioned, powered by async-FNL, which is my library for making asynchronous programming available to Fennel users. This library is a port of Clojure Core Async. So basically, I just took all of the concepts available in Clojure Core Async and mapped them onto coroutines in Lua. So we are not using generators and state machines. Instead, we are using pure Lua coroutines. So this library is a bit more powerful than Clojure Core Async in this regard, because you can write code more naturally than you would with Clojure, but that's besides the point. So by using Core Async, we can implement sockets as bidirectional non-blocking asynchronous channels. So we have a translation layer that takes in a socket and returns us back a channel that we can use by the means of Core Async operations. And each socket is then baked by 2 asynchronous threads, one for reading data and one for sending data. So nothing ever blocks. What I like about Lua, what I like about Fennel, is that Lua is very flexible, and most of the libraries for Lua are also quite flexible as a result. So I like to bend Lua to my needs in some way, and I wanted to make non-blocking asynchronous operations out of Lua Socket, which famously don't support non-blocking operations and asynchronous operation as well. So to do that, I just set the timeout time for a socket to 0, which makes it basically non-blocking. If it's not ready, it just immediately rejects and the code continues. So we can work around that and implement our own asynchronous operations around sockets. So the socket channel is, as I said, a combo channel with a sender and a receiver. And puts to this channel are handled by the sender thread, and takes from this channel are handled by the receiver thread. So it doesn't work as a regular channel in the way that you can put data in and then take it back out. If you put data in, it will be sent through the socket, and only the result will appear back in this channel once the socket responds with some data. So it's a bidirectional stream instead of a regular channel, but you can still work with it as an asynchronous channel in Core Async. The sender thread handles this by checking if the socket is ready to accept by using the socket select operation, and if not, it just sleeps for 10 milliseconds because that's the minimal amount of sleep time we can have in this library. And this sleep is handled asynchronously, so nothing is really blocked. It just goes and sleeps in an asynchronous way. If it's ready, it just sends data, and if timeout occurs while sending the data, it will requeue itself to resend remaining data after the socket is ready again, because the socket may not be ready to receive any more data at that time. And it loops until closed. Receiver thread works similarly, except it tries to read data in a chunk, and you can control this chunk. It supports the same kind of chunks that Lua socket supports, so you can read a line from the server, you can read everything from the server, or you can read an amount of bytes from the server, and it will try to receive that amount of data. Again, if timeout occurs, it will sleep, collect partially received data into a table, and return it only once the chunk was read in full. So you can read chunk by chunk, and so the streaming now works. And again, it loops until closed. So closing either one closes the other one, because why wouldn't it? And closing the socket also closes both sender and receiver threads. So we manage our resources pretty sound here. Then there is the parser, and the parser was implemented from scratch, and we have two main parsers here: the response parser and the request parser, because we also have the server. The response parser is responsible for parsing the status line, headers, content, and it supports content as multipart, as chunked encoding, and as a row encoding when you receive a raw string. However, underneath, there is always a stream, except for when dealing with multipart, which I'll show later. The request parser works similarly. It parses the request status line, the headers, the content, and it can support, again, the content encoded as multipart, stream, or a chunked encoding. It doesn't support raw encoding, because when we are dealing with requests, we don't ever want to read the request body. It's the client's job to do that. So the body reader is implemented for a chunked request and for multi-part request. When the server sends us some data, we create a reader from this socket channel, basically. So this reader then will try to receive any amount of data that you want it to read from the socket. As I mentioned, with readers, you can use read an amount of bytes, and it will try to read this amount of bytes from the socket channel, because this is supported. With multipart, it's a bit different, because we have multiple parts in the same request, and we want to go through them one by one usually. So each part is being represented as a state of a special Lua iterator. So the multipart request will return you an iterator that you can consume. In actuality, it simply reads the data from the server response. It finds the multipart separation headers, and once it meets that, it returns you a value from the iterator, which is the name of this part, and then it returns you the reader, which contains the content of this part. So when you advance this iterator, it will consume any unread part that it was not read by the user. But if you need to, you can read everything inside a for loop, basically. So, and again, because it's streamable, because it's asynchronous, it never actually blocks anything more than required to read some amount of data. So you can make all of your applications extremely robust in the way that they handle multiple requests, even when working with multipart, which I think is nice. And I haven't seen this in many other clients which make multipart in some weird ways. I think iterator works great here. And there is the server, and the server is really simple. It has only one method. It starts the server, and then you can stop it by storing the server object here. So it's asynchronous again. You simply supply it with a function that takes in parsed request and some parameters to tell where it should run. In this example, it can run on localhost on this port. Each client is assigned to its own asynchronous thread, which means that, again, you can have a server with a lot of clients. They don't need to fight for resources. They can do stuff asynchronously. So you should write your handlers in an asynchronous way, ideally, because if you have many clients, they will park when they can't do anything and will give other clients time to work with. And it's a really simple server that I tried to use to implement an example code with server send events. So here you can see how the server can be used. We have a wrapper, like a middleware for working with events, and we accept a channel that will contain our events, and we try to read from this channel. This is using core async again, because as I mentioned, the handler is running inside of the asynchronous context, so we can use asynchronous operations inside of it. And we are working, if we have an event, we send it to the out channel and we simply return the out channel. With heartbeats, we again accept a channel timeout that we want to wait. We create another channel, and we are working with this channel to check if we have an event in it or we have a timeout, and we decide what to do, either send the timeout or send the event back to our channel. And the head itself is really simple. We just check on the parsed request what was the path, and if the path is events and the method is get, then okay, we can give the client all of the events as a continuous stream. So we respond as with this data structure that contains the status 200, the headers that we have text event stream, and our body is actually a channel. So this channel events is created right here. So we create a channel, we subscribe it to events stream, so it's like a pub sub situation inside of a core async again, and then we return channel directly from our server. Because this server is using core async, it can work with channels as supplied as body, and it will stream its contents to the client when they become available in this channel. If the method was notify, it means that some of the clients wanted to notify all other clients with events. So here we receive an event and register this event, sending it to any consumer. So anyone subscribed to this handle will receive this event. So basically, this is a small like web chat implemented purely on SSE technology. And then we just start this server with this handler, and it basically works. You can read more about that in my blog. And that's basically everything from me. This time I had a small issue making my talk a little bit bigger because I injured my finger really badly, so I cannot write more than that. So I hope it was enough, and I hope it was interesting. Thank you.
That's great. Thank you. At the beginning, I was going to ask you, like, oh, what did you need from a JSON client, a JSON parser that you didn't find? But then when you explained that trick about printing the null but keeping it as nil in the table, that's really cool. I have never seen that done before.
I also forgot to mention that this JSON library also has custom encoders that you can create. So if you have custom data structures implemented with meta methods, you can still make them like encodable in JSON. So for example, if you have a zero-based array with like indexing starting from 0, you can still encode it as JSON without fiddling with like writing your own custom like function and using it everywhere before you pass it to the JSON. You can just register. Especially that's the other part that is missing from a lot of JSON libraries.
Yeah. Awesome. Well, yeah. Thanks for sharing this. We'll leave a couple. We'll just see if there's any questions here, but so far we don't have anything. So yeah, Ambrose is up next, and yeah, we'll oh, I'm gonna do the stream restart again real quick. It's just to be sure.
How's my sound?
We're back. Yeah, sounds good.
Okay.
Go ahead, take it away. Thanks.
All right. So a couple of months ago, I had actually this has been a long-running project of mine, which I've been writing type closure for about 10 years now, and just accruing new platforms, and Fennel's always been on my mind. And this year I actually made a few steps towards it, towards supporting Fennel in type closure. And this talk is really sort of an architecture sort of, I would love to get feedback, because there's a lot of blind spots here, and a lot of things that are, well, it was a bit of a brute force approach, so you'll see. But the sort of higher level insight here is that Fennel and closure have very similar idioms, like higher order functions, macros, and from a type system, and so from a tooling point of view, there's a lot we can share. And yeah, like all of the talks today have been taking inspiration from the closure ecosystem, and this is basically the same thing here, except here we're combining typed closure, which is an optional type system for closure, with maybe Fennel. Like, what would that look like? So this talk is about how we might build a static type checker for Fennel by reusing all the work that I put in creating a type checker for closure. And sort of the work sort of starts by figuring out what is platform dependent and what is platform independent. So, and this sort of also motivates why I'd want to do this project in the first place, because all the stuff on the right, it takes a lot of effort to implement them, and they apply to a lot of, that they sort of target the commonalities between these closure variants. So, for example, symbolic analysis allows you to have the type system understand higher order functions without having to annotate everything. So instead of having to say you map over a collection, you don't have to annotate the function. Like that was part of my PhD dissertation, and then it took me a few years to actually implement it. I don't want to do that again. And I have this nice local type inference implementation, polymorphic function invocations, like all the for all A to B, you know, figuring out what the A's and B's are. Like that's basically the same for every type system. Well, for many, there's a whole category of type systems which type closure is in, that this is the implementation is basically fixed, so I don't need to do it again. The type checker itself is actually parallelized. It uses virtual threads. Each file is checked in parallel, and each form actually in the top level file is checked in parallel. And then I'm working on caching as well, so you don't have to recheck things once you've checked them. Lua doesn't have the greatest parallelism story, and I also don't want to implement them again. And there's all these base types and base subtyping rules, like functions are the same everywhere. That they have variable arguments that sometimes they're polymorphic. And actually on the right here, there should be macros. Macros are a key similarity, and we have macro rules. So you can tell the type checker how to deal with a particular macro. But sort of the stuff on the left is the scary part. We need to re-implement all this stuff for Fennel. Somehow type closure needs to understand how to read Fennel, how to expand it, how to analyze it, which is sort of understanding whether this list of syntax, is this an invocation? Is this a macro call? Is this a primitive? Is this an interrupt? So once we've analyzed that, we need to have the type checker understand what the interrupt even does. Like, what is dot on a table or colon on a table? And so we'll need a custom checker to actually go over the analyzed results and hook into all the stuff on the right. Like if it's actually an invocation, then pull in this neat implementation of polymorphic function invocation. And then interop itself, we have tables, which that's one of the big asterisks here, is I have no idea how to deal with them. But one big problem that Lua has with type checking is that you often have a let bound table at the beginning of your function. You have a top level function, and then you say let this table, and it's just like an empty table. Like you have no idea what's in it. But there's a really key opportunity for Fennel, because we use macros to abstract over that. So we use for loops and each and iCollect and all that stuff. For a type checker, like we don't need to expand that. We can understand that directly. So that's one of the reasons why there are existing type checkers for Lua, and they come against these problems, and that's why I'm a little more interested in doing it for Fennel than, say, Lua itself, because there are these opportunities, and the more we build these abstractions, the more directly we can type check things, and with less annotations and less tricks, and hopefully more direct, faster implementations. So it's kind of an exciting, new area to see if these ideas work. So I'm going to run over a sort of demo, a Hello World demo that vaguely works in a sort of, I ran it in a REPL once, but I'm hoping to give you a sense of the architecture and how I've glued all this together in this prototype. Okay, so here's some Fennel code. This is all just copy pasted from the current GitHub of type closure. If you want to check it out, you can find type closure on the internet, but I don't try and run this or anything unless you're really excited about this. You should email me. But here, this demo is in so type closure is a mono repo, has like all the type checkers, Fennel, closure script, closure, and it also has this example projects thing. So we have an example project, Fennel. So we're just going to pretend that this is your new Fennel project, and you want to type check this file. So how are you going to do it? So let's just walk through this. So the first thing, we're going to import type Fennel, which is something I'm going to explain exactly what that is in a second. But it's effectively just a file of macros that doesn't do anything from the Lua side. So for example, one thing you might want to do in a type system is declare a type alias. But this isn't something you'd want to deploy in your Lua artifact, right? So you'll see how we deal with the actual macro. But the idea is that type closure, type Fennel / closure will be able to see this macro, but it won't be relevant in the resulting artifact. And we can annotate top level functions. So here's a function. We say like, let's annotate demo func to be this type alias, which is this thing here, which I have an extra slide. I'm at the very end. I'm debating whether to go to it because it kind of, I'm just going to go to it. This is a really interesting case. So one question is, couldn't we just have these types be comments and just pass the comments? The reason we don't want to do that is because of compositionality. We can write our own macros that then look like first-class type, like first-class typed Fennel operations, and that's something that's also that is sort of more exciting than, say, a type Lua. Like you couldn't do this because we don't have macros, but to have what is this? So this is a function that it recreates the same, this is basically saying we can annotate this form to be string to string, and we're just sort of expanding out. It doesn't matter what it is, but you can see that you don't need any special. This is just Lua. Sorry, this is just Fennel. This is just Fennel. So that's what we're leaning into here. Okay. So this is just a Fennel function, and what we want the type checker to do, the closure type checker, would be to understand that this is the primitive fun, Fennel's fun somehow, that is going to type check this function, and it's going to make sure that the expected type is the one that we've annotated here. And we'd be using this, all the stuff on the right here would be coming into play. Like, okay, we just need to plug in, we just need to analyze the Fennel just enough so we can plug in the rest of the infrastructure. And then at the end here, we're calling the function. So type Fennel would have to know that this demo func here is referring to this local here, and that this is a string, and that strings are they're related to themselves. So subtyping comes into play. Yeah. So I'm effectively saying we'd want the type system to work as a type system, but it helped because there's closure and Fennel happening here. I thought it might help to just go step by step. So everything we've seen so far is Fennel. We'll see Fennel in the next few slides as well, but then we'll jump to the closure backend at the end. But let's see what typed Fennel is. And it uses the coolest thing that Fennel has, that the Fennel ecosystem has had in a long time, which is Andre's Deps Fennel, which has already been mentioned. So in our example project, we have a root Deps Fennel, and it brings in typed closure as a dependency. And here we're saying we have a source file, which is our, what did we call it? Type Fennel demo, which is under source. So this paths thing is how you tell Fennel, the Fennel compiler, here's our runtime Fennel code. This is what we actually want to compile into Lua and deploy. And our dependencies here, yeah, so what is this type closure thing? So it's actually, it's pointing to the root of type closure, and it's in another submodule. This is kind of confusing, but effectively what type Fennel is, type Fennel.Fennel, yeah, is a macro file. And that's, yeah, Deps Fennel makes this easy. Like, no one needs to care if it's a macro or runtime file. We just say it's a macro, yeah, it's a macro path. And that's going to point to the type Fennel runtime, which it's not really the runtime, but you only need compile time things to hook up. But there's not really a better way to describe it, I guess. I would call it the runtime. And I guess it's lean enough that it doesn't exist. You know, it's just macros. Okay, and okay, so now we're looking at typed Fennel.Fennel. This is still a Fennel file, but it's a macro file. So the thing on the right is going to be the export at the very end. We're exporting some macros, and you'll see that these macros are really, really boring. Like, it returns nil. The alias is purely for static analysis. This macro expands to nil, and the idea is that type closure or the analyzer would just use this to register my type as being union of nil and string, and then just sort of throw it away. And the same thing with an would be declaring the type of a top level variable. Although, so in type closure, an is all about top level vars, but because of Fennel's scoping rules, I guess an could be the current local scope. That's kind of neat that it's very uniform in the same way that fennel could be. But this doesn't actually work today, but that's the way it would evolve. And form is sort of like a type ascription. Yeah, we're ascribing a type. And it just returns form. So at runtime, it's just 1 + 2. But at compile time, the type checker can see, oh, we want to enforce that 1 + 2 is an int. And so it's really just a way of embedding type information into your Fennel program. And it doesn't weigh down the runtime. So let's zoom back out to the demo. This was our file that we wanted to type check. We imported type fennel. We set up some aliases and annotations. Now the question is, and let's assume that we've type checked this somehow, how do we even check this? If we're in Clojure, how do we check this in Fennel? And here's I don't know if this will do it justice. This is sort of difficult to get your ducks all in a row. But here's an interesting case. This do-to macro, the type checker doesn't actually need to know what do-to is. All it needs to know is how to expand it, because it expands to quite easy code. Here's the spoiler over here. If you do-to open a file and then you immediately close it, all it does is let bind x to IO open foo, close it, and then return x. So instead of teaching type fennel how to type check do-to specifically, it'd be great if type fennel could expand it and then type check the expansion. So let's go back to the shopping list here. This is where we need to be able to read fennel code, at least in this prototype. I don't know if this is a sustainable thing, but we want to read fennel code from Clojure, and we want to be able to expand it from Clojure, and to analyze it enough to know when to expand it or whether to expand it. So here's a high-level idea of the sort of flow here. So if we have this inert file, this fennel file that has do-to IO open close, and we want to be able to type check this with type fennel, well, the entry point is going to be a Clojure program. So it's going to have to use a Clojure implementation of the fennel reader. You could imagine some other way, but let's just say that this is the way. We're going to re-implement the fennel reader in Clojure, and then turn it into an abstract syntax tree that represents the compilation, the sort of the intermediate stages of compilation for a fennel file. And if we analyze this and convert it into Clojure, okay, I'm going to skip ahead to what is happening here. So the first step is we need to read this. So what does that mean? That means that we have a Clojure program that can take a string of fennel and returns a Clojure data structure. And as far as I can tell, it's a pretty clean one-to-one correspondence. So here's the actual top level description. So if you have a list in Fennel, that gets converted to Clojure lists. Same with vectors. Tables become maps. Symbols, Fennel symbols. Actually, I don't remember what a Fennel symbol is. So no, it's just not a runtime concept. That's it. It's a compile time concept. Yeah, okay. So they're just Clojure symbols. Fennel strings are strings. Numbers are numbers. Booleans are booleans. Nil is nil. This triple dot is the symbol triple dot, which I'm guessing works. Yeah, it's probably unambiguous. So the fennel keyword are just closure strings because fennel doesn't really have keywords. So as far as I can tell, this is a pretty faithful mapping from one to the other. And basically the rest of this file is just implementing that. Like I actually transliterated this using Claude Code by feeding in the fennel parser. And I got out this, mostly working AI output. So that helped me get along to the next stage, which is actually representing the unexpanded fennel in Clojure to then get to the next stage, which is there's sort of a missing place here, which is we have to query whether this do to is a macro in the current fennel file. And it's just a bunch of, pushing around of some logic. But you can imagine we serialize it back to a string, pull it, and then send it to fennel to expand, and then deserialize it back. And then we get a let here. And then we can plug it back in to the common parts, the shared parts of type Clojure, which knows how to deal with let binding. And there's basically local bindings need to be gen simmed for reasons of type soundness. So that's another thing. It's just a bunch of details writing a type system. You just don't want to do it twice. It's best for everyone. So that's the reader. So the analyzer is, it's pretty much a direct port of tools analyzer from Clojure, except it's my fork that has one extra, you saw it here, this unanalyzed node. And the idea here is that, so tools analyzer can't actually represent an unanalyzed piece of fennel. But as I was saying before, it's really important to get intermediate representations of a fennel expansion, because you have a lot of information in, say, an each form or an iCollect form that you can then use to infer types. So it's basically, it's almost a non-starter to just macro expand everything. So that's the main difference. So yeah, for example here, this happens after we read the fennel. Yeah, this integrates with the fennel reader that's written in Clojure. And if it's a list, we dispatch on the first symbol, which, there should be a Lua. So here's Lua, we pass Lua into a, yeah, you can see some platform dependent things like var values Lua, or and I think are primitives in fennel, but not in Clojure. But yeah, this is just to say that this file is specifically for analyzing fennel code. And here's the part that sort of brings it all together, which is you're in Clojure and you want to macro expand a fennel form, and we're effectively shelling out to deps fennel and running a fennel file that will know how to expand something. It's a little silly at the moment. You would hope maybe there'd be some shared state or like long-running REPL where you could communicate things. You wouldn't have to reevaluate things. But I'm also like, there are performance concerns, but also if we go back to the existing features of type Clojure, we have this idea of caching. So you should only have to recheck files that change. So maybe we could get away with something. I mean, probably not, but it's good enough for this prototype. So this is a bit of a lie, but I haven't finished these things on the left, but I have prototyped the things on the left that to a degree where I'm happy with the results. So I've written a Fennel reader enclosure, a Fennel analyzer enclosure, a Fennel expander from closure that calls into Fennel, and the actual runtime, the annotation macros, and then had a proof of concept where we use deps Fennel to hook it all up. The sort of huge elephant in the room is Lua is very mutable, and type closure does not deal with that very well. So I need to think very hard about table types. Maybe but we have really good support for immutable table-like things. So maybe there's an intermediate stage where we just pretend it's immutable and we could bootstrap things. That's probably a terrible idea, but it's hard to get anything working in typed Fennel without having a type for tables, so something has to give. And yeah, I was alluding before, if we preserve the context of these macros, each and iCollect, we can have custom rules in the type checker. So I haven't written any of those rules. And we have to teach typed Fennel about the interrupt rules of Lua. And that's at the bottom of the list for the good reason. I don't know. Because Lua is deployed to so many different places with different requirements, and I don't know how to think about that yet. I think I have my work cut out for me with these first two things, and I think that's about it. I can take questions. Yeah.
Cool. Thanks. That is a lot to take in, I gotta say. Wow. First question from me is, have you looked into using Cobalt, which will let you run Lua code from the JVM?
Oh, really? No.
I'm gonna paste this in here for you. It's basically a port of the Lua virtual machine to Java. That'll let you do some interop there. And so you could definitely run the closure, the Fennel compiler directly without shelling out. You might have to rewrite a lot of your stuff. I don't know, but definitely
not much there. The thing I liked about deps using deps Fennel was that the user story is very straightforward. Like say like the entire ecosystem uses deps Fennel. Like you can just say like have a requirement that you teach type Fennel which profile to activate, which alias to activate, and then you get your, I can't remember what the class path is called in Lua. But that's the real trick. Like to have to have these macros being expanded in the back end, you sort of need to have a fully working environment somehow. The way that deps Fennel brings it all together, it's I think that's one of the keys, and it's not so much about where. That's the main property I'd want to preserve, is to be able to communicate that class path implicitly, and how to resolve dependencies.
Cool. Looks like Andrew's got a question, and then one from Algernon after that. So go ahead, Andre.
Yeah, if you already asked all of your questions. So there is, it's a shame that Zero is not here, because I think they might have a lot of input, but we kind of have this project called FennelLS, which can do a lot of analysis. It can also like expand macros and analyze them. So maybe you should look into FennelLS as a library for like analyzing, or maybe into their implementation of the reader, because they have their own reader of Fennel, because they have to deal with analysis a little bit more than Fennel does for like language server purposes. So it's not strictly a question, but have you looked into it? And maybe if you do, why didn't you choose to use it, or if you didn't, then you should probably try to look into it.
Yeah. I found I've been trying to kickstart this project for a year or so. I talked to Phil about it on and off, and I found it easier to get started if everything was in closure land, basically. I didn't know enough Fennel. I mean, I'm not that advanced. I use Fennel in like Reaper, and I helped like give feedback for Dep's Fennel, but like building developer tools written in Fennel, that's just beyond my capacity, my capability. Just I wanted to test out the architecture. I had a lot of difficulty, like even like dealing with terminals and shells. Like I had difficulties with readline getting in the way and sending things. I was just going down the wrong path, and I just wanted to. It was really in the spirit of having a working prototype, minimal viable product, and I'm pretty dismissive of all the actual concrete approaches I've taken, but I think the architecture, is pretty well motivated, wanting to reuse. Those are the things that I'm married to. Wanting to reuse, liking the JVM for say these large parallelized jobs, not necessarily wanting to port it all to Lua, doubling the workload of maintenance. And one other thing that I didn't mention was that sort of the rationale here is, it's not that I particularly think that Fennel needs a type system. It's more that the more architectures, the more backends that I support in type closure, it just gets the design sort of improves. So I'm working on Closure CLR, and probably Closure Dart and Fennel is on the list, and it's really nice to see the abstractions and sort of the I think it's one of the it's a really interesting way to study what closure even is. So like this slide here saying, like, well, it's really like the stuff on the right is like, that's core to what closure is. Like the to be able to have to teach a machine how to say, like, understand an if statement. I didn't even mention like conditional control flow. Like I guess Fennel uses pattern matching, but like, I don't know, that like you can sort of use similar ways to model both from a type system point of view. So I like learning about what closure is, like these insights about closure's design. So that's where I'm coming from, rather than say pushing like we all need a type system, which I don't necessarily think is true.
Yeah. So I have a second question, if I may.
Go.
So like I can relate to the point, like understanding what closure is, because one of my projects, and I vaguely remember you emailing me about it, maybe, which is closure like core port to Fennel. Maybe not. So like you mentioned that you don't know Fennel that well, and I didn't mean to like use Fennel LS as a basis to write everything in Fennel. I actually meant like looking at Fennel LS to maybe spice up your own implementation in Closure, because then again, it's mostly similar. But what brings me to Fennel CLGlib, which is my library that ports a lot of Closure core to Fennel. Maybe you could check that out, because again, when you are not really familiar with Fennel, but you are already familiar with Closure, I think Fennel CLGlib is what I made for exactly this like case. When you know how to write Closure, you don't know exactly how to write Fennel, and this is like a transition layer. Because it implements a lot of Closure. It has like lazy sequences, like mutable data structure. So maybe you can look into that and ease your way into Fennel a bit. And also, like, I'm really interested in seeing if it can be used in something like more or less serious. So maybe writing like Clojure-like code for analyzing Fennel inside of a Clojure project can like use this library. So again, maybe like look into that. Although I will say that it's mostly an art project. It's not like meant for serious development, but even though I'm willing to work on it to make it like usable in serious examples, in serious projects. So I think Fennel CLG can be at least utilized here to write Fennel parts that you need in a Clojure style. So
yeah, I'm familiar. Yeah, that's an awesome library. I'm glad you're back in the community because I forked it somewhere and now I don't need to. I can point back to your stuff.
Yeah.
So yeah, you do awesome stuff. I follow all your stuff.
Thanks.
Yeah, it's mostly the editor stuff, the LSP stuff. I'm sort of not purposely, but I'm pretty agnostic about the Emacs Vim where it meets these programming language tooling. Like I'm sort of at a more on the compiler side of things rather than the editor side. So that's more of the intimidation. But I think if someone tried to write, it's a really interesting marriage. Say if we had your Clojure Fennel library, have people type check code that is written in that style, because we could almost directly reuse, say, the typing rules, share the typing rules with type Clojure and type Fennel in those cases. If you have like the for loop, it's exactly the same in both. Like that's the stuff that makes this all worth it, all the great sharing of these, the connections between these communities.
I don't have the for loop.
Oh, you don't?
No. For loop in Clojure is so hard to like understand how it's implemented that I have the loop macro, but not for.
So I have an interesting story so I've spent this year understanding the for and do seek, because it turns out that do seek is exponential in its expansion, and I figured out how to make it linear. So the more loop variables you use, that it doubles the output, and it's basically because each time you have a chunked and a non-chunked seek branch, and it becomes exponential. So maybe 2026 I'll be pushing that implementation back upstream. But yeah, if you do end up hit me up if you want an actual non-exponential. For these, like, Clojure scripts probably also exponential. So like for these embedded output, like it's just really bad to have exponential. I don't know how this happened. Like if you have a do seek with a go loop in it and then deploy it to a Clojure script, I don't understand. So I think that's going to be a really valuable, and hopefully in the process of actually advocating for that change, I'll have blog posts that actually explain how this macro even works. So
yeah,
it
will be great.
Yeah, so look forward to that.
We also had a similar problem with like our pattern matching, which is, by the way, just an if statement on steroids. So it's nothing like, and it also grew exponentially if you had a lot of branches that reuse the same like checks. And I think Zero managed to fix that. Yeah. Awesome. Again, thank you it's a great talk. I'm really excited about this.
Thanks for your questions. Any other questions?
Cool. Algernon had one. Do you want to just ask it, or I can read it out loud? If
I could just ask it. Yeah. So the environment I'm working with, Fennel, is embedded into another program, and a lot of types and variables and whatnot I supply to the Fennel side of things comes from the environment. They are not native types to Lua. Do you have any goals or ideas whether you want to support typing information for custom user data?
Yeah, that's really all this stuff, isn't it? Like I don't really. Yeah, that's what I was getting at. Like I don't understand. I know that you can say like you see data structures from Lua and somehow link them, and I don't know. It sounds like a
Okay.
lot. Maybe there's a way to formulate them that. Well, I guess you don't need to tell Lua too much about these data structures, right? So maybe we can get away with that on the typed Fennel side as well. We just need to say like what fields or what functions or just how it operates. Maybe map it onto these more primitive function types that we already have. That's sort of how type closure works. Like if you want to override a method in Java method, you just say like, here's a type closure type to use instead of the one you can infer from a reflection. Like that would sort of be the vibe that I'd go for. And maybe
I think that would work. Yeah. Okay.
And like maybe we could use Deps Fennel to then upload a shared, community maintained version that you would just add the annotation library, and then somehow type closure type Fennel would scan the class path, add all the annotation namespaces automatically. That's sort of what I'd like. Yeah, you'd have like a typed closure.fennel at the root of the class path, and you find them all. That sort of thing.
Because it seems like you can kind of just treat them like tables that have fewer features. Like they have some methods in them, but you can't like iterate over them. You can't like set arbitrary new fields on them. So it seems like if you have tables working, this is just like a subset of that. I don't know.
Yeah. I guess, maybe you'd want to parameterize some types. Like if you had a primitive list, a list of A, like something like that. Like I guess the tables themselves would have functions that take these primitives. It would probably just end up being just the Lua. It would just be an extra primitive type and then it would be business as usual, which, see the first point here, which is I haven't figured out how to do table types yet. So,
Great. Well, if we don't have any more questions, then I think we can move on to our final speaker here, Algernon. So let me restart the live. All right, we're good. Go ahead and take it away.
And if all goes well, my screen is shared. So my name is Algernon. I like Lisp, and I also very much dislike various crawlers which hammer my sites. So about a year ago, I started to fight back a little bit. Initially, I wrote a program called iocane, which was a garbage generator, and used the reverse proxy to identify the bots and then do stuff with them, serve them garbage. This worked for a little while, but after a while it became obvious that the domain-specific language of the reverse proxy I used was not really up to the task. I really wanted to use a real programming language to deal with all the variations and whatnot. So I ended up embedding a little programming language or a script language into my little garbage generation tool. Because my tool is written in Rust, I looked for embeddable languages which work well in Rust. The one I originally settled on was called Roto. It's a statically typed language which compiles to machine code. It's a very nice, very performant, but it's also very limited. And because I come from a very Lispy background, I also wanted to use something else, something which have a lot more parentheses. So I decided to embed Lua because embedding Lua is easy. It's what it was made for. And if I can embed Lua, then I can embed Fennel. So I did that. So what my talk about today will be is we're going to have a little look at what iocane can do, and we'll write a very small script in Fennel which can get rid of a whole lot of crawlers. So what iocane provides is a scripting environment and a whole lot of tools and functions, both to check various properties about the requests. There's documentation about everything it can do. As you can see, just the table of contents is pretty long. So the script itself is basically about two functions. We have a decide function, which takes a request and its output is a string. This tells iocane what to do with the request. And there's the output function, which also takes a request and the decision made in the former function. Why these two is separate is a whole different topic and doesn't matter today. What matters here is once we set up the basics, we tell iocane that we want a HTTP server listening it on whatever port and request handler declared elsewhere, which is going to be written in Fennel, and this will be it. So what we'll do is implement 3 ifs in a trench code. This thing here. After observing the crawlers for a couple of months, I came up with 3 very easy checks, which let me identify them. If the user agent is listed in AI robots.txt, which is an awesome project which collects all the AI crawlers that identify themselves, then we serve it a poisoned reply. Why we serve it a poisoned reply, I will explain that in a little bit. If the user agent has a Chrome or Firefox component and it doesn't have a segfetch mode header, we also serve it a poisoned reply. And if we discover a request coming to a poisoned URL, we also send it a poisoned reply. The reason we send the poisoned reply is that a lot of crawlers just collect all the URLs. But sometimes they give those URLs to real Chrome browsers, which you can't really identify as crawlers because they behave like any other browser, because they are. But if you fill their queue with poisoned URLs, then they will have nothing else to visit but those ones. And if you can identify them by the URL, which you serve to the primitive crawlers, then you can catch the real Chrome ones too. So how do we do that? On my screen, you can see, hopefully, very simple request handler. All it does is return this not for us thing, which is a string default. And the output function just says stuff works. So it doesn't really do anything, but let's try it. If I curl it, somewhere here, stuff works, yay. If I tell it a different user agent, still stuff works. So let's do something more interesting. So the first rule was if the user agent is listed in AI robots.txt, we'll serve it a reply. We'll do the replying later. We'll first do the identification. So how do we do that? We have this function, which I wrote ahead of time. This basically loads a JSON file, collects all the keys, and turns it into an iocane pattern matcher. This is a function. A function provided by iocane. What it does is basically match a number of patterns in parallel very efficiently. It's a little bit faster than a regular expression, but it can only match complete substrings, which is perfect for our use case. So we'll declare a local variable called matchers, because why not? And we loaded the file, and then we'll write a little function. And every matcher has a matches function. So if the user agent header matches any of the robots listed in the file, then we'll return garbage. And we have this all tests list here, which the decide function uses to decide what to do. I'll explain that function in a moment. So
just real quick, you got a typo up in local matchers. Your pattern needs an N on it. Oh, JSON keys to pattern.
Ah, yeah, thank you. Okay, so the decide function here is using this wonderful accumulate function to iterate over every function in all tests and calls every function with the request as a parameter until the outcome is not nil, which is why I used when here, because if it doesn't match, then when returns a nil. So let's see what this does. Hopefully I didn't screw it up. I did. Oh, okay. So we don't need the nest there. there. So because GPT-bot appears in the AI robots txt, this should return garbage, but it doesn't. I made a typo somewhere. Oh yeah, here. Unfortunate. Okay, so it still returns stuff, but we can only print the decision here to make sure we're doing the right thing. So as you can see, decision here is garbage, and if I remove GPT-bot, then it's the default. Yay. So first, if in the trench code works, but we want to drive them into a maze, but only if the decision is to serve them garbage. So we do if decision is not for us, then we'll set the response status to 421. This is misdirected request. The idea is that you configure your reverse proxy to pipe everything through iocane, and if iocane sends back a misdirected request, then serve the real content, otherwise serve whatever iocane told you. And if we want to generate garbage, we'll cheat a little bit. We won't use anything from iocane, not context content type. I'm not going to type this. No, I'll just paste it. So we serve a very tiny amount of HTML with a poisoned URL. Anything that contains abracadabra will be treated as garbage, and then we don't need these two. Okay, let's see how this works. So if we don't set a user agent, it just does a misdirected request. If I set it to GPT-bot, then it serves me the garbage. Yay. The wonderful thing about Fennel is that functions are just like any other kind of data. It's not like that in Roto. So Fennel makes it a whole lot easier to arrange your code in a sensible way. For example, I can implement the second if similarly in a very simple function and just compose it with the rest. I just add it to the all tests list, and the accumulate function will iterate over it. So the next function is like, let's call it isBrowser. We'll write the matcher in a moment. Except I want an end here. So if the browser, or if the request user agent header matches the thing we'll write in a bit, and If the sac fetch mode header is nil, then we'll send it garbage. So let's do this is browser matcher, which is just a regexp matcher. There we go. So a very simple regular expression. If the match string contains Chrome or Firefox followed by a slash, it will match. And we add it to the all tests. And I can type. See if it works. Let's set the user agents to Firefox, whatever. And I made a typo somewhere. Which line? Okay, that's not really. Oh, yeah, there's a typo. Yay. So we got the garbage back. And if we send a sac fetch mode header, then we get the misdirected request back. Yay, we identified these two. So the third if in a trench coat is checking the poisoned URL. Since we already serve poisoned URLs right here, we can easily match those with another pattern, or a regex, or a substring match, whatever. I like to use Iocane's matcher because it has the same structure as anything else, and it's implemented in Rust. So if we want to use multiple identifiers and choose randomly, we could do that too. Makes it a little bit harder to identify what we're doing. So for now, I'll use a simple pattern matcher. And do a very similar function as the rest. And we start it up. If we visit the base URL, everything works. If it contains abracadabra, then I screwed something up. Matchers. Oh, yeah. There we go. So now we handle poisoned URLs as well. And all it took was a little bit more than one page of, I think, very readable and composable Fennel. The same thing in Roto would take like at least 2 files, and it would look a whole lot uglier. Which is the major reason I added support for Fennel, because it makes it nicer. It may be a little bit slower than Roto. A little bit slower is about an order of magnitude slower. but it's still fast enough to run it for every request, because the majority of the time will be spent on decoding TLS anyway. So compared to that, running a few pages of Fennel code is, well, not really measurable, not really comparable. And it just looks nice. It looks elegant, at least to me, who misses writing Lisp code, so to say. And yeah, that was pretty much my talk, I think. I just wanted to show that, how should I say it? So a lot of Lua is embedded in various other programs. And Fennel has, so it can be embedded in the same places and provides a whole lot more readable code than Lua at virtually no cost. You can use it not just for, I don't know, building applications or web servers or a full stack. You can also use it wherever Lua can be embedded, and that's fantastic. So, yeah. If you have any questions, I'm very happy to answer.
Oh, thanks a lot. That was great. I should that we are using iocane on the Fennel wiki, which was getting hit pretty hard when it first got set up. But now that I've put up iocane there, I've basically been able to forget about it. So that's been a big relief. So little success story there. Yeah.
There are a couple of other places who use iocane, Codeberg, for example. They recently replaced Anubis with it.
Awesome.
That was pretty nice to hear.
That's huge. Yeah. Cool.
But actually, they are not using Fennel. They are using Proto, but maybe
we'll get them later.
Yeah.
I had one quick question. What's the purpose of the default entry as in the alt test list? Is there if you left out, it would just end up as nil? Would that do the same thing, or?
Well, that depends on how you write the output function. So whatever the decide function returns will get piped into output. So if you return nil from decide and then teach output to handle as serving the real contents or not for us, that's pretty much the same thing, yeah.
Yeah, cool. Great. Any other questions? All right. So that's it for the talks. Thank you so much to Algernon and to everyone who's presented. Really enjoyed seeing what y'all have put together here. Very cool to see it come together here. I'm gonna just leave the stream going here. So if you're viewing on YouTube and you want to join on the Jitsi, there's you can just come hang out. And if you refresh well, I'll just pull it up here. Let's see. Come on. If you refresh the FennelConf page, you can see here there's a link. I added the 5th talk is hanging out on the stream after the talks. So there's a link to it there. You can join, but I understand it's pretty late for some of our people. So I imagine people in Europe are going to want to head off. But if anyone else wants to hang out for longer, we can use the chat for that. But yeah, go ahead.
Unfortunately, I will have to leave because I have kids to put to bed. So thank you very much for the talks, and thank you very much for having me. Have a nice evening.
Yeah, great. Good night.
Goodbye.
Good night.